You've probably heard that large language models are just predicting the next word, that they're fancy autocomplete. And that's technically true. But here's what nobody tells you. If that's all they were doing, they couldn't write a poem, solve a math problem, or hold a conversation that feels like it actually understands you. So, how does a machine that's just guessing the next word end up sounding like it knows what it's talking about? The answer is stranger than you think. Let's start with the obvious. You type a sentence into ChatGPT. It spits back a response.
How?
The model looks at the words you gave it, and then it tries to predict the most likely next word. That's it. One word at a time. But here's the catch. It doesn't just look at the last word. It looks at every single word you've written so far, and it weighs them all against each other. It's like reading a sentence and trying to guess the next word, but you're not just guessing based on the last word. You're guessing based on the entire context. And that's where the magic starts. But that's not the whole story. Because if the model only looked at the words in your prompt, it would be useless. It would have no knowledge of the world, no understanding of grammar, facts, or logic. So where does that come from? Training. Massive training. The model is fed billions of sentences from the internet, books, articles, forums, code, everything. And during training, it's not memorizing those sentences. It's learning patterns. It learns that after the word because there's usually a reason. It learns that the capital of France is almost always followed by Paris. It learns that if someone says, "I'm sad," the next word is often because or about. But here's the thing. It doesn't know what sad means. It doesn't feel sadness. It just knows that in the data, the word sad is statistically linked to certain other words. And that's enough. And here's what most people miss. The model doesn't just learn simple word associations. It learns hierarchies of meaning. It learns that dog and cat are both animals, but dog is more likely to appear with bark and cat with meow. It learns that bank can mean a financial institution or the side of a river, and it figures out which one you mean based on the words around it. This is called context embedding. The model turns every word into a vector, a list of numbers, that represents its meaning in relation to every other word. And those vectors get refined over billions of examples until the model can tell the difference between "I went to the bank to deposit money" and "I sat on the bank of the river." It doesn't know what a river is, but it knows the pattern. Now, here's where it gets really interesting. The model doesn't just predict the next word once. It predicts it, then adds that word to the sequence, then predicts the next one, and so on. That's called autoregressive generation. And because it's building on its own output, it can produce long, coherent responses. But there's a problem. If the model always picked the most likely next word, it would be boring. It would always say the most predictable thing. So instead, it introduces randomness. It samples from a probability distribution. Sometimes it picks the most likely word, sometimes the second most likely, sometimes a less likely one. That's why you can ask the same question twice and get different answers. The model is deliberately being creative. But that creativity has a dark side. Because the model doesn't know truth from falsehood. It only knows what's statistically likely. If you ask it a question that's rare in its training data, it will still generate an answer. It will just make something up. This is called hallucination. And it's not a bug. It's a feature of how the model works. The model is designed to produce plausible-sounding text, not accurate text. And that's why you can't trust it blindly. It's a mirror of the internet, with all its brilliance and all its nonsense. So, let's bring this back to you. Every time you use a large language model, you're interacting with a system that has no consciousness, no understanding, no intent. It's a statistical engine that has learned to mimic human language so well that it feels like it's thinking. But it's not. It's just predicting the next word over and over billions of times until it sounds like it knows what it's talking about. And that's the real insight. Intelligence, as we experience it in these models, is not about understanding. It's about pattern recognition at a scale so vast that it becomes indistinguishable from understanding. The next time you get a perfect answer from an AI, remember, it didn't know the answer. It just knew the pattern. And that pattern was you.